coming to part D. It says, what purity value is exceeded by exactly 3% of the population? Okay. Now, remember, my population consists of normally distributed oxygen tube purity percentages, okay, which with location parameter 99.61 and scale parameter 0.08. So I have several oxygen tubes like that. The average, the location parameter of their distribution is 99.61 and scale parameter is 0.08. So the question asks, what purity value is exceeded by exactly 3% of the population? So there is a certain purity value, oxygen purity value, which is exceeded by only 3% of the population, which means only 3% of the population has a larger oxygen purity than this certain value which is being asked. Okay, so they are asking the question is asking a value for which only 3% of the population has a higher purity percentage, and remaining 97% is going to have a lower purity percentage than that. Okay, so the question basically asking this. So let me show this again in Paint. So in Paint, this time I'm not going to draw the standard normal distribution. This time I am going to draw the original distribution. So in the original distribution, we have 99.61 as the location parameter. 99.61 as the location parameter, and the scale parameter is 0.08 in this question. And the question is asking me this: there is a certain threshold value X here, and only 3% of the population exceeds that value. So what is this X? So it is being asked, the probability of X being less than or equal to that X value should be equal to 0.97. Okay, so the question is asking this. Now, the rest is mathematics. The rest is standardization and stuff. So the question asks that there is a certain purity percentage such that only 3% of the population exceeds that purity percentage. And this means the 97% is going to have a lesser purity percentage than this value. Okay? And now we are going to solve this equation by standardizing the inequality by subtracting the location parameter from both sides and divide the difference to the scale parameter. Then we will get the cumulative distribution function of the standard normal random variable at x minus 99.61 divided by 0.08. This is supposed to be 0.97. And at 0.97, my friends, at 0.97, the critical value is approximately 1.88. So let me show you that in the CDF table. So I am looking for a cumulative probability of 0.99, a cumulative probability of, 97. Where is 97? So 0.97. Not this value, but very close to this value, right? So we have 0.9699, which is close to 97, and that is 1.80, obviously 8. Okay, so 1.88 approximately. However, if you apply linear approximation, you will realize that it should be 1.881, and that value is the critical value for the standard normal distribution, and that critical value should be equal to x minus 99.61 over 0.08. And from here we see that 99.76 is the critical threshold value here. Okay, so let me show you the Paint here. So that x value here is 99.76. Okay, 76. And in part C, if you remember, we have asked similar thing. We have said that the area here is going to be 0.07, and that critical value here was found as 99.76 492. Okay, so do you see that this value is less than that value, which is the location parameter, and that value is greater than the location parameter? Remember now, location parameter divides the distribution into two equal parts. Here is 0.50. This part is also 0.50. Okay, so this distribution is symmetric around this. Therefore, this value was less than the location parameter, and this value was greater than the location parameter. Now, when you solve such questions, in the end, you can check if your answer can be true or not by looking at the original picture here.